Right, okay, we can start. In our previous lesson, we were talking about arrays, and we had actually covered one-dimensional arrays. Right, these are some of the arrays that we declared, created, and initialized. Right, so we have got this integer array that we defined there using that approach, and then we declared a double array, and then we also declared a string array with those elements. Right, then I used this advanced for loop, or the for each loop, to iterate over that collection of elements. Right, you can actually assign one array to another array variable. For example, what I can do is I can maybe just delete all these other arrays, and then maybe remain with this one, only the double array. So what we are saying is that you can create we can create another double array, right? And then after creating that double array, you can assign the values. You can assign the values, or assign that array rather to this array that we are creating. Maybe I can call it new double array. Right, there are two approaches of defining your array variables. Right, in our previous lesson we were using this approach where you put the index operator immediately after the data type, or where we are associating the data type with the index operator. But you can also put the index operator after the data type like this, but I don't usually use this approach. Instead, I would always want to associate the index operator with the data type. But you can also do this, where you put the index operator after the data type, or associate the index operator with the variable name. Right, then equals, so I can say equals equals DA like that. So here I'm creating this array, right, and then I assign it to DA. These two arrays are now pointing to the same object in memory. They are now pointing to the same object in memory, because arrays are objects. The moment you assign one array reference to another array variable, the two end up pointing to the same object in memory, and they are now aliases, or they are two references pointing to the same object. There are two references pointing to the same object. The problem with this is that if you are dealing with mutable variables, if you change one, it will also result in the other one being affected. For example, here at position 1 we have got 67.9. At position 1 we have got 67.9. I can change that by simply saying NDA 1 is equal to what? Then I give it a new value, maybe 23.0, like this. Right, after doing this, if I now try to print the value, system.out.println, the value at position 1 of this array DA you realize that it would also have been what? It would also have been affected. So if I say system.out.println, then I put DA1, right? I now expect it to print what? To print 23. But in DA1, in DA at position 1, we actually had what? 67.9. But since these two are now aliases and they are pointing to the same object in memory, if we change the value at position 1, it will also affect that other what? Other array, or the original what? Original array. So if I save this and run, right, this is the output that I now get. So you need to be very, very careful when you are dealing with what? With objects. If you assign one object variable to another what? Another object variable, you end up creating what? Aliases. Or having a situation whereby you have two variables or two references which are pointing to the same object in memory. So if you modify one, it will also affect the other one. So you need to be very, very careful, right? So how do you make sure that a copy of this array is created, and then that copy is assigned to this new array NDA that we are creating? You use a method which is called clone. You use a method which is called clone. So here, if I wanted to create a copy of DA, or a clone of what? Of DA, what I simply do is I say DA.clone. DA.clone, like what? Like that. The clone method is one of the methods which is defined in the ultimate superclass of all the classes in Java, the object, right? So we can just what? We can just invoke that. We can just invoke that because our object is defined in java.lang what? Package. You don't need to import anything here. But this clone method, it returns an object of type what? Object. It returns an object of type object, which is supposed to be cast into what? Into this type. But at times it can actually implicitly convert it what? Convert it into the appropriate data type, such that there won't be any need to what? Any need to cast. Such that if I now print, as you can now see, we are now getting, if I say system.out.println DA1, I am now getting 67.9. But if I say NDA1, I now get a different what? A different value, because these two are now separate what? Separate objects, or we have created a copy or a clone of what? A clone of DA, and then we assigned it to what? To NDA. Right, like I was saying, we could have cloned it, and the proper way of cloning is to maybe just specify the what? The type that we want to cast it to. You just specify the type that you want to cast it to or convert it to. So here you can simply say double. This is the type, like this. So it will be cast to what? To double. It will be cast to double. But even if you don't want, even if you don't cast it, to implicitly cast it to what? To the appropriate what? Appropriate type. Right. So that if I run, I still get the same what? The same output. Right. There is also another method. There is also another method, the system.array copy, which you can use if you want to copy maybe certain elements in an array to another what? Another array. If you want to copy a subset of elements, maybe from DA into maybe a new array, like maybe NDA, you can use the system.array copy function. Right. Let me maybe just demonstrate how you can use that function. let me create another array here, a double array again. Maybe I'm going to call it CDA. Then I say equals, right? Then system dot array copy, right? If you are using an intelligent ID like the one that I am using, those are the parameters where it's saying object, that is the source, then int, the source position, and then object destination, and then int destination position, and then int what, int length, and it returns what, doesn't return any value, right? So here I then say array copy, system dot array copy, right? Then you pass the what, you pass the argument, right? So the first one is the from what, from array, or the source array, maybe from array. Then maybe from what, from start. What is the starting position? We are saying maybe we want to copy from DA. We want to copy from DA, which is the from array, right? And then we are saying from what, from start. We want to copy from this array, right? Starting at position what, then you specify the from what, from start position. Then after that you specify the to array, or the destination array, the to array. So we are saying we want to copy from array A, starting at a particular what position, and we are copying to array A. In array A, we also need to specify the starting position where we want to start what, pasting or adding or inserting elements. To start position, right? Then the number of elements that you want to copy. So it then specify the number of elements that you want to copy, right? So from array, our from array is DA. We want to copy from DA. Starting at what position? I can specify any valid position. My array is 2 4 elements, right? So the valid positions are from position 0 to position what? Position 3. So I can specify the start position. I want to start maybe copying at position 1. Then where am I copying to? I'm copying to this new array, CDA. Sorry, my statement is not correct. I'm copying to CDA. Here I should have just created the array. And then if this statement is a standalone statement, I will rectify that later. Then to start in this new array, what is the starting position? I can maybe say I want to start at position 0, and how many elements do I want to copy from DA? Then I specify that maybe I want to copy 2 or 3 elements, right? You need to make sure that these indices are what or these arguments are correct, because there's no way you can say you started at position 1 and you want to copy 10 elements when you have only 4 elements in the what, in the array. You need to make sure that those arguments are what, are correct. So we are saying this is supposed to be a standalone what, a standalone statement, and here we can just create a new array and say new maybe double, right? Then we specify the what, we specify the length, maybe 10 or whatever length. Then after that we simply have that statement, system dot array. Sorry, I have omitted the right. So here we are creating this array CDA, and we want it to hold 10 elements, but the elements are going to come from DA. So we now want to copy the elements from DA starting at position 1, and we want to copy what? We want to copy 2 elements. So it is supposed to copy what? This and that. These are the 2 elements that we are going to what? We are going to copy, right? Then after that, if we try to print this, what do we get? CDA. If we just pass it as an argument of the print line method like that, right, we get an address of where the object is. So you can't print what? You can't print an object. You can't print an object. We are actually getting an address of the object. We are getting an address of the object. So what we can do is we can maybe print the individual object, or the object at position 0, or we can iterate using maybe the ordinary for loop or the for each loop. So if we just want to extract the value at position 0, we now have 67.1.9. So that's the system.array copy function, which you can actually use to copy elements from one array to another to another array. Are there any questions? Right, if there are no questions, let's move on to the next subtopic. These were one-dimensional arrays. We now want to move on to multi-dimensional arrays. Arrays, where you can have maybe a 2-dimensional array, 3-dimensional array, 4-dimensional array, and so on. Right. So you define multi-dimensional arrays with as many index operators as you might want. So if it is a single-dimensional array, you only use one index operator. Only use one index operator. If it is now a 2-dimensional, you use 2 index operators. If it's 3-dimensional, you use 3 index operators, and so on. Right? So what I'm going to do is I'm going to start by demonstrating how you can define a 2-dimensional array. So I'm going to delete this and then just modify that array so that it becomes a 2-dimensional array. So what I can do is I can just add 2 index operators there. Right, after adding 2 index operators, I also need to add 2 index operators here, and then I change the way that I initialize my 2-dimensional array. So we are now saying that a 2-dimensional array, it has what? It has rows and what? Rows and columns. It has rows and columns. So you need to specify here how many rows and how many columns. If you are defining a 2-dimensional array, you need to specify the number of rows and the number of what? Number of columns. Right? So maybe without using this shorthand, let me maybe just remove this shorthand, but I'll come back to it. Maybe we want to define an array, a 2-dimensional array with maybe 4 columns and maybe 3 rows, or 2 columns and 5 rows, or 3 rows and 4 columns. Right? So the first index operator, it is supposed to specify, or we are supposed to specify the number of what? The number of rows. So here we are supposed to have the rows. Then here we are supposed to have what? The columns. So we can actually define some variables here and say int maybe rows is equal to maybe 5, then comma, columns is equal to 6. I think in one of our lessons I indicated that you should try as much as possible not to do what? To try this at home. Right, it affects readability. Maybe you need maybe to define each variable and initialize it on a separate line, but you can use that shortcut where I'm just saying int rows is equal to 5, columns is equal to what? 6. It affects readability. right? So now I have got rows and what and columns like that. I have rows and what and columns, right? So I now have a two-dimensional what? A two-dimensional array with 5 rows and 6 columns. We have got two types of languages. So two types of arrays. For all the what? All the programming languages. It's either the language follows maybe a row major or a column what? A column major what? Principle. If it is a row major, it means you need to start by what? Start by rows, or listing the what? Listing the rows. If it is a column major, you start by what? Start by listing the what? The columns, right? So Java arrays, they are row major type of what? Type of arrays, right? So we start with the rows and then what? Then the columns, right? So here I can now initialize my elements like this. So we are saying we've got 5 what? We have got 5 rows. So the indices for our rows, the indices for our rows, they are ranging from 0 to what? 0 to 4. And the indices for our columns are ranging from what? From 0 to 5. So we maybe have something like, we have got something like this. Let me just insert a table here. We are saying we have got 5 what? 5 rows and 6 what? 6 columns. Right, 5 rows, 6 columns. So we have got something like what? Like this. That's a two-dimensional what? A two-dimensional array, right? So we identify these cells or positions using the what? Using the row index and the column what? Column index. So the value at this position, the value at this position, so this will be what? The first column is column what? Column 0, column 1, column 2 up to column 5. This is row 0, row 1, row 2, row 3, row 4. So the value at this position, it's the indices will be 0 what? 0 0. Row 0, column 0. Then this one, it's row 0, column 1. That one, row 0, column 2. That one, row 0, column what? Column 5. Then this one, the last one, that's row what? Row 4, column what? Column 5. And this one, that's row 4, column what? Column 0. So each and every element in a two-dimensional what? In a two-dimensional array is identified by 2 indices. One index will be representing the row, then index rather will be representing the row, then the other index will be representing the what? The column. Right? So if you want to store a value at a particular position, maybe like this, you need to know the what? The row and the what? And the column number. Again, if you want to fetch values, you use the same indices. The row index and the column what? The column index. Right? So I can now initialize my what? My two-dimensional array. How do I initialize? I use the name of what? The name of the array, DA, right? Then I specify the what? The row. Then I specify the what? The column. Maybe at that position I would want to store maybe 30.6. Then maybe at position 01 I would want to store maybe 45.89. So this is how you store what? This is how you store the what? The values. This is how you store the values. If you want to access the values, use the array structure plus the index what? Index operators. So for example, if I want to extract the value at position 0, 0, I will simply say system dot out dot print line then DA 0, 0. So I expect it to fetch the value at position 0, 0 or the value at row 0, column what? Column 0. And then it will print that what? That value. And what we have at that position, we have got 30.6. So if I run, that is what I expect to get, right, as you can see. So we can actually initialize all the positions using this this approach. We can initialize all the positions using this approach. But you can also use that other approach of initializing the array by just specifying the elements, and then you enclose them in curly braces. Separate the elements with what? With commas. We can also use that approach, where we said you can just after your index operators, you just put some curly braces, and then you list the elements separated with what? With the commas. But here our elements are now sort of compound elements, or they are actually arrays on their own. Because if you look at this two-dimensional table, if you look at the first row, right, that row, it is actually what? It is actually an array on its own. It's a one-dimensional array. That row which I've highlighted, it's actually a what? It is actually a one-dimensional array. Just like the second row is also a one-dimensional what? It's a one-dimensional array. Each of these rows is a one-dimensional what? Is a one-dimensional array. Right? So if you are defining a two-dimensional array, it's sort of a situation whereby you are defining an array of an array. You are defining an array of an array. Right? So we are simply saying this two-dimensional array, it's an array with 4 one-dimensional arrays, or five rather, because we have got 1, 2, 3, 4, 5. So we are saying it's an array, but that array is 5 one-dimensional arrays. Right? So if we want to initialize, we can take each row as an array. So you put it in a what? In curly braces as a set. So we can simply do this. If I go back to my script, so we indicated that when you now want to combine the array declaration, creation, and initialization in one statement, if you want to combine those 3, you need to remove the what? The dimensions. You need to remove the dimensions. That's the first thing. Then you need to specify the what? You need to specify the value. So we are saying here we have got what? Some one-dimensional arrays. We have got some one-dimensional arrays. So we can have maybe the first one like that. Then we add some what? We add some elements there. Right? Maybe 0.6. Then comma 67.89, comma 98.2, comma then 5.8. That's the first one. That is the first row. Right? After defining the first row, you put a comma rather. Right? Then you define the second row. Right? Then you add the elements. 1.4, 45 point start, 2.3, so 2.5, 5.7, right? Then you have another what? Another row. I'm just going to have 3 rows. 4.6, 1.6, 78.5, 90.1. Right, so that's the last one. That is the last one. So that's the other approach that you can use apart from using this one, this approach. Apart from doing this, you can just initialize your array like what? Like that. You can initialize your array like that. Let me. Right. So here, what type of array have we defined here? In terms of the number of columns, the number of rows. Huh? Yes. So that's not 4 rows. Three rows, 4 columns. So that's a 3 by what? A 3 by 4 matrix, or a 3 by 4 what? Array. Are we together? Right. So that's how you define a 2-dimensional array. If it is a 3-dimensional array, you put 3 index operators there. If it's a 4-dimensional array, you put 4 index operators and so on. So if it's now a 3-dimensional, you now be having columns, rows, and what? And maybe planes. Right? So again, you start with your what? You start with your rows, followed by columns, then lastly your what? Your planes. Right. So how then do we iterate over this kind of a collection using a looping construct? We want to maybe quickly access each element which is in the collection, and then we print it. Want to access or get each element, and then we print it. We can do that using a what? Using a for loop. You can either use the for each or advanced for loop, or you can use the traditional what? Traditional for loop. Right? I'm going to demonstrate how you can do that using both approaches. Right, let me start with the traditional for loop. So here we are saying we have got 3 rows. We have got 3 rows and how many columns? And 4 columns. So what is the range of our indices? What is the index for the top left corner or top left element? 0, 0. What about the last element? Don't take this for granted. What is the index of the last element? We are getting different answers, and most of the answers are wrong. It's 2, 3, right? So the last element, the position is 2, what? Is 2, 3, right? So what we are going to do is, we need to use 2 loops. We need to use 2 loops, or embed 1 loop inside another loop, The first one is going to be keeping track of what? Or the outer loop is going to be keeping track of the number of what? The number of rows. The outer loop. Then the inner loop is going to keep track the number of what? Number of columns. Are we together? So we are saying we are going to extract a row. Then we iterate over the elements which are in that row, because that row is sort of a one-dimensional array. Then we fetch the next row, we iterate over the elements, we fetch the next row, iterate over the elements, like that. So the outer loop is going to be keeping track of what? Keeping track of the rows, while the inner one will be keeping track of what? Of the columns. So here we can define the outer what? Outer for loop. What will be the int, our loop control variable? We can initialize it to what? To 0. What will be the terminating condition here? X is supposed to be what? What's the condition? This is the loop which is going to keep track of the number of columns. Huh? Less than what? Some are saying 3, some are saying 4. Some are not saying anything. Yes. We are saying the outer loop is tracking the number of what? Number of rows. How many rows do we have? And what is the range of the indices for our rows? 0 to 2. So we are saying x is supposed to be less than what? Less than 3 or less than or equal to 2. Right? So you can say that less than 3 or less than or equal to 2. Right? So here maybe I can say less than 3. Then the condition x plus plus. Right? Then we have the body of the what? We have the body of the for loop. So inside we are now going to define our what? Our loop, which is going to be what? Tracking the columns. So we can maybe use a different what? A different variable here, j or k. Again we initialize it to 0. What's the condition now? Less than what? 5. Where are you getting 5 from? Less than 4. Right? Then we say j plus plus. Right? Then inside that loop we also have the curly brace to mark the beginning and end of that particular what block. Right? Then what are we supposed to do? We just want to print the what? Print the elements. Just want to print the elements. So I can simply say system.out print line. System.out print line. What do I want to print here? I want to print this is the name of the array, which is DA, right? And then I specify the indices. DA. You always start with what? With the row, because arrays in Java, they are row major what type of arrays. So the row is what? The row is X. So you put your X there. Then the columns, we are using J. Right? So if we run, maybe we might want to, both if I run, I'm going to have a situation whereby each maybe element is on a separate line, because I've used the print line there. Let me just run so that you see the output. Then we rectify that. So that's the output. Each element is on a separate line, but we might want to format the output such that maybe each row is on a separate what? In a separate line. So how do we do that? We want elements in one row to be printed on one line. What are you supposed to do? Huh? We use print here, then what else? Then what? Where? Here. It's just the same as saying print line. That will not work. We have to do it outside the what? Outside the first loop. So this inner loop is going to allow us to print a what? A row. Right? Whatever row, if it's the first row depending with the value of x. So this will allow us to print the first row. When we finish printing the first row, we now need to move to the second what? Second row. So before we move on to the second row, we might just need to have what? A print line which doesn't take an argument, or we can say print, then in quotes slash what? Slash n. Or we can use print line. Or we can use slash n, %n, or right. So if I do this, again we are going to have one problem with the output. You can't tell because the numbers have not been separated. So you might need maybe to just have a separator here. So what I can do is maybe there I can simply say plus what? Plus space, or even tab space. Let me maybe use tab space. If it's tab space, you can just use slash what? Slash t like that. So I'm going to have a tab space. I print a number, then I leave a tab space, print the next number, tab space, and so on. So if I now run, I now have my output like that. So that's my two-dimensional array, which is a 3 by what? A 3 by 4 array. Right. If you look at the way I defined this array, it had a uniform number of rows and columns throughout. What if I remove some of the elements? Maybe here I remove one element, that 5.7. Then here I add another element, maybe 45.8. What happens? The first row now is one, two, three, four. Second row is 3 elements. Third row is 5 elements. We only have a problem with what? With our loop. Because if I run, let me save that first. Program is crashed. Right, I think I need to stop it, and then I start, because we are having problems with the what? With the number of rows and columns, number of columns rather, because we have fixed what? We have fixed the columns to what? Was it 4? Right, in our for loop. But defining an array like this is not what? Is not a problem. It's actually allowed. You can define an array like what? Like that. It's actually referred to as a ragged what? A ragged array, where maybe you have got a number of columns which are not maybe uniform. So if you want to have such a type of an array, you can actually only define what? You can actually define the number of columns. The number of columns. And then maybe you don't define the number of what? Then you don't define the number of rows. for example, if I can maybe just cut this part. If I want to define my array like this, I can maybe specify only the number of what? The number of columns, like maybe 5. Then I don't specify the number of rows. So it means that the number of rows is going to be varying. Number of rows is going to be varying. You can have a variable number of columns rather, not rows. But if you try to do it the other way around, you can't vary the number of what? The number of rows, but you can only vary the number of columns. If you do that, you actually get what? Actually get an error, because you need to specify the number of what? The number of rows, but the number of columns can vary. Right, so that was the original definition. So like I was saying, you can use what? You can use this kind of a loop, or you can use the for each. How can we use the for each here? How can we use the advanced for loop? Huh? Yes. For int. This is not int. Double. Then what? Okay.
And then you put the outer one of the
This. Then what?
No, you have to put for double D array. Double array.
Like this. Right?
And then you put telegraph. And then now for double.
What is it? Right, then D. Was a poor choice of a variable. Right, then we have got what? Then we have our set there. Right, so that's the other one. That's the other approach. You can actually what? You can actually use the advanced for loop or the for each. Right. So this one, we are extracting what? We are extracting a row at a time. So if we do this, we are saying for each one-dimensional array. We are saying for each one-dimensional array in this two-dimensional array. So we fetch the first one, the first one-dimensional array or the first row. Then when we fetch that row, it's sort of what? Sort of an array. We then say for each element in that one-dimensional array, then you what? Then you print. Then it next iteration it will fetch the next row, right? Then in the inner loop it fetches an element at a time. So if we run this, maybe we just need to format the. How can we format this? Maybe put a print, maybe like the previous one. Then we can say just say plus. Then maybe I can just leave a space like that. Then after that I just print what? I just print a blank line. Right? Then I run. I hope it's not going to crash this time. Right, here we are. That's the output. For 3-dimensional arrays, 4-dimensional, multi-dimensional arrays, the procedure is more or less the same. Just increase the number of the number of index operators. I think that's all about arrays. Are there any questions before we move on to something else? Right, I think we can have a short break and then we'll proceed after the break.